Thank you everyone for joining us for this webinar, Installed Line Array Solutions for Sporting Facilities, presented by Rick Kamlet. My name is Laura Lawrence and I'm the Global Marketing Director at Harman. So just a few things before we get started. Everyone on the call is muted to keep down noise levels during the webinar. However, there is a chat function where you can submit questions to the presenter and he'll try to answer as many questions as possible at the end. This webinar is being recorded and the link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control. And we'd like to encourage you to take a look at the different webinars in our Learning Sessions Workshop series that can be found on pro.harman.com. We're adding new sessions daily. We have over 25 sessions scheduled for July and August, so watch for those coming up on the calendar. And now I'd like to introduce you to my colleague, Rick Kamlet, the presenter for today's webinar. Rick has managed numerous JBL Professional loudspeaker product lines over the last 30 years, and he currently oversees the engineered and commercial installation loudspeaker lines. His roles have included product development, engineering, business development, field support, and educational training. Now I'm going to pass it over to you, Rick.
All right, thank you very much, Laura. So today's webinar is about loudspeakers for sports facilities. See if I can get my slides to advance. There we go. All right. So I'm Senior Global Product Line Manager for Installation Loudspeakers. We've got on the line with us also Brad Ricks and Jim Burdett, who are experts in the design of these speakers into various applications. I'd like to thank you all for joining us today, and thank you all for your time. As Laura mentioned, the process for questions is to send them via either chat function in WebEx or to hold them until the end of the presentation. We'll be answering them at that time. There are many types of sound system configurations that can be used for sporting facilities. One of the most popular designs is a highly distributed speaker system like these facilities that are shown here. Highly distributed systems use a large number of speakers. Each listener tends to be within the coverage zone of one of those speakers. Signal alignment tends to flow either from the outside of the facility inward toward the center or from the inside toward the outside. A highly distributed system can work extremely well when it's done right. It may well be that for any particular facility, a number of different kinds of designs could work fine. Identifying the appropriate design approach depends on many factors. Things like the architecture, the kind of sport that's been taking place there at the facility, the role of the sound system and what it plays in that particular sport, the SPL requirements, the amount of bass that's needed, the available attachment locations, code requirements, visual objectives, the budget, and so many more factors. There are positives and negatives for each kind of system configuration, and there are different critical design considerations for each. Like I mentioned, a fully distributed system can sound very nice, and each patron is covered by a speaker that's fairly close to them. However, it can be expensive to install all those speakers in all those different locations. Takes a lot of cabling. You may not have the ideal mounting positions available. You've got to time align the signals. For this system that we're looking at here, time zero is at the back of the stadium, and then the other speakers get delayed to those speakers. Plus, something that some people may not consider is that the speakers in this kind of system tend to be fairly small in size, and therefore the horns are small. The stated coverage pattern in that speaker only holds down to a certain frequency. Below that frequency, a considerable amount of sound can wrap around the speaker cabinets and project in the wrong direction. That can mess up the time alignment in the seating section behind it. And to minimize the wraparound, it's sometimes necessary to high pass the speakers at a fairly high frequency. But again, when those systems are done well, they can work quite well. What I'm going to talk about today are some of the larger, newer, updated loudspeakers that can be utilized in sports facilities. As with any speaker, think of them as a tool in a toolkit. Many speakers we make that can be used in highly distributed systems that's one set of tools. VLA I and VLA Compact speakers are another set of tools. We're going to get into VLA Compact series in depth, but to orient you about how VLA Compact fits into the market, let me start by telling you about the larger VLA and the updated VLA I speakers. VLA stands for Versatile Line Array. So going back in history, historically, the Soldier Field project in 2003 utilized what was an early prototype of VLA. Large modules of collinear mid-bass drivers were arranged next to smaller modules of high-frequency only drivers. This arrangement effectively met the goal of the project, which was to have even coverage and a continuous SPL capability of 105 dB at a distance of approximately 600 feet from the speakers. While we sometimes think of sound systems in NFL stadiums as being replaced every 6 to 10 years, this same system is still in operation at Soldier Field 16 years later. I'm told the cabinets are now a bit worn, but the staff's been diligent about doing regular maintenance, so it's still working well. For those not familiar, this gives you an idea about what's inside a VLA speaker. And this is the original design VLA. The design basically combines line array technology with horn loading. So we've got versions with horizontal coverage patterns of 40, 60, or 90 degrees. That's essentially long throw, medium throw, and short throw. It's important to have multiple coverage options in these kind of installations because installation type line arrays typically consist of mixing coverage patterns within the array. The seating section that each cabinet is aimed at is usually each seating section is at a different distance from the array and therefore requires different horizontal coverages. So developed with sports facilities originally in mind, VLAs immediately became a favorite in arenas. The defined horizontal coverage kept energy within the pattern so that there was less overlap between adjacent areas. That improved speech intelligibility and musical clarity. VLAs are in use in many NHL, National Hockey League, ice hockey facilities and NBA basketball arenas. This venue, US Bank Stadium, opened in 2016 to very positive reviews, especially for consistency of coverage, sound level capability, and sound quality. VLAs are used in 9 NFL stadiums and will be the main speakers in the 2 NFL, the new stadiums that will be opening later this year. You can see how the full range cabinets here are curved, and that helps define the angle of the vertical coverage. And then the subwoofers are installed in a straight line behind those cabinets. This is one of the many ways that these speakers can be used. For those of you who are familiar with our CBT columns, these are kind of in a way sort of like huge CBT columns with the low frequency drivers located directly behind the high frequency ones and in a coaxial topology. Or another way to use them, the very high output also allows these speakers to be used as the main speakers to cover most of a stadium from an end zone or scoreboard location. Here the VLAs are covered, they cover a large part of this 87,000 seat college stadium. By our last count, VLA speakers are utilized in at least 25 major US college stadiums and a lot of smaller and high school stadiums, and well, the larger high school stadiums in the South. So this is BC Place in Vancouver, They use a full range, the full range modules in a wide angle arc. And the things that look like subwoofers behind them are actually cable baskets. So what's new is that we recently updated these full-size VLA modules. The new modules are called VLA I. There are a number of improvements. First, talking about the cabinet itself, the sides are now rectangular instead of trapezoidal. People don't tend to use them in side-by-side splayed arrays, that would normally require trapezoidal sides to the cabinet. Making the cabinet sides rectangular simplifies the rigging systems and makes them easier to install, and it also provides more cubic volume inside the cabinets for deeper bass. Probably the biggest change is that we updated the drivers. The low-frequency drivers were updated to advanced dual-coil neodymium differential drive models. That gives them improved performance, greater low-frequency extension, higher sensitivity, greater power handling, and higher overall output. And the high-frequency driver was also updated. That also results in higher output. Okay, that was a quick introduction to the full-size VLA I series. Now let me switch over to talking about our fairly new VLA Compact speakers. So there was a need in the marketplace and in our lineup for a smaller, dedicated version that could be used in smaller arrays. We needed ones that could be used in more highly distributed cluster applications, as well as for main scoreboard arrays for smaller venues. They needed to be smaller and allow for lower overall system price. Toward that, one goal was to cover a greater vertical coverage angle per cabinet so that fewer cabinets would be required. Other goals were to make the full range models two-way rather than three-way, allow them to be driven full range from a single amplifier channel if the user wanted to do that. That can substantially lower the cost for amplifiers and therefore lower the overall system cost. The series needed to have outdoor capability so that they could be used in outdoor areas without needing to get special order versions or upgraded weather treatment. So these pictures that we've got here show two kinds of systems. The first one is an end zone system at Mercer University in the state of Georgia, and the second one shows a distributed cluster system at Tottenham Football Club Stadium in the UK. We expect that these will be popular configurations for these speakers in sports facilities. I'll be talking more about these systems in greater depth in a minute, but let me start with a general overview of the speakers themselves. So these are, there are two full range models with two different coverage patterns, one being more for long throw and the other for short throw. They're horn loaded, which helps to increase the efficiency as well as the pattern control. Each cabinet houses two low frequency drivers and three high frequency drivers. We'll talk about the drivers in a minute. So JBL has also developed advanced FIR tunings. So for those not familiar with FIR, as opposed to traditional IIR tunings, provides for linear phase filtering, which in turn allows for improved phase response across the spectrum. So this is important for proper arrayability of multiple speakers, and that's how these speakers are used in arrays. So let's look at the drivers more closely. First, as you can see, the drivers are very densely packed together. That gives a very high output for the size of the cabinet. All these drivers are double voice coil drivers. The 2261s each have two voice coils, and the C2415Ks also each have two voice coils. That means that from a drive perspective, the sound from each of these cabinets is driven by 4 voice coils for the low frequency and 6 voice coils for the high frequencies. And just a note about durability, these drivers are not brand new. They're the same road tested drivers as we've got in our VTX20 touring sound systems. So the cabinets are lightweight and compact. I won't go through all these figures, but note that the trapezoidal angles on the top and bottom panels allow for arraying at up to 15 degrees of vertical splay. So again, you can use fewer cabinets to cover listening space. This photo shows the internal acoustic horn loading. The configuration aligns the wavefronts from the drivers coherently, and it flattens the vertical wavefront for more ideal arraying between multiple cabinets. You can also see that while there are ports near the left and the right edges, the sound from the 10-inch low-frequency drivers comes from closer to the center. That reduces the amount of horizontal lobing that you would get from multiple left and right drivers. What you're seeing here is all inside the speaker and is covered by a full-size weather-resistant grille. So you don't see any of this when they're actually in use. I also wanted to point out the nice-looking cover on the side. That visually conceals the bulk of the arraying hardware. Okay, so moving to the dedicated low-frequency cabinet, it's the same width as the full-range enclosures, so it can be arrayed along with them. The cabinet is sealed, in other words, it's non-ported. This was done to ensure a high degree of weather resistance. The cabinet fills in the bottom end of the audio spectrum down to the mid-50 hertz range. I won't, again, read through this list of features, but let me highlight that the drivers are also dual coil differential drive transducers, and these are also outdoor rated right out of the carton. And as you can see, it's quite compact too, and the height is only 20 inches tall. For some systems, you might want to connect the subwoofers in cardioid configuration to cancel out much of the low-frequency sound that would otherwise project backward from the array. We have a dedicated DSP tuning available just for that, and we make an accessory kit that allows you to neatly wire the low-frequency cabinets together into that kind of cardioid configuration without having any cabling that's exposed on either the back or the front of the array. The wiring connects through the tops and the bottoms of the cabinets. We also have different DSP presets for how you want to cross them over with the full range models. So one of the tunings overlaps them with the full range cabinet. That reinforces the low mid frequency output capability up to 150 hertz. Or if you prefer, the other preset uses them like a traditional subwoofer, in other words, crossing over to the mid-high cabinets around 80 hertz in a non-overlapping configuration. This shows what the angle plates for the rigging the speakers looks like, and how you set the splay angles of the speakers. So if, for example, you need to splay this two speakers by 3.8 degrees, you would insert the bolts through the 4 holes that are marked 3.8 degrees, and then into the threaded locations on the speakers. The bolts through the 2 top holes go into the top cabinet, and the bolts through the 2 bottom holes go into the bottom cabinet. The available splay angles were chosen to allow for common progressive array configurations, and that's usually what's needed for covering listening plane evenly. Here's a diagram showing a 6-cabinet array. It contains 2 low-frequency boxes and 4 full-range cabinets. You can see in the diagram on the left the nice-looking side trim cover that I mentioned before, and that helps to make the array look neat. Okay, about which amplifiers to use with these speakers. The VLA speakers are made to be driven from the Crown DCI-N or DCI-DA amplifiers. We provide the advanced FIR tunings for this combination. The speakers are not designed to be driven with standard IIR tunings, and we don't provide parameters for that. All this information about compatibility with amplifiers is in the user guide. So the tunings call up a set of FIR filters specifically made for these speakers, and then you can add your own extra filters. So this shows you some of the added filters. In addition to the FIR filters, so there are 5 fully parametric user filters for each cabinet. The top 2 that you see here are filters. They get applied to all the cabinets in the array. One is a low-pass shelf that compensates for the low-frequency buildup that occurs as arrays get longer. The other compensates for atmospheric absorption, and that's particularly useful for when you're throwing longer distances. These are filters that you should apply to all the cabinets in an array. And then there are 3 circuit filters at the bottom that are specific to each cabinet or set of cabinets, and the installer defines. It's called a circuit filter because you might be using a single amp channel to drive 2 cabinets. In that case, the EQ would apply equally to both cabinets. They're both on the same circuit. And in that case, the EQ, but if you've got 1 amp channel per cabinet, then these filters get applied to that single cabinet. The FIR tunings are posted on each of the VLAC model web pages. The new tunings allow the C2100 and C265, the 2 full range models, to combine better in mixed arrays. The new tuning files are called Revision 2. And there's a document posted that gives you step-by-step instructions about how to install the tunings into the amplifier for anyone who hasn't done that before. The user guide contains diagrams, both how to wire the cabinets and some other things. This diagram shows how you would connect the left-hand terminals if you'd want to use the built-in passive crossover. There's a different diagram in there showing how you would use the right-hand terminals for bypassing the built-in crossover for if you want to bi-amplify your speakers. Like with any of our line array calculators, the VLAC calculator provides a sectional view for viewing and optimizing the coverage, plus rigging information. So starting with this tab, the acoustic modeling tab, shown here, is for designing the performance and coverage of the array. Here we see an 8-cabinet array covering 3 listening planes. This is the tab you use for determining the best array location, the number of cabinets, which cabinets to use, inter-enclosure splay angles, proper gain, delay, EQ, and those kinds of things. You use it for designing the array to give the most consistent coverage from front to back and to see what kind of SPL you expect to get. You can see the frequency response window at up to 6 locations, along with SPL mapping, isobars, and attenuation plots. In this screen capture, you can see in the frequency response chart in the bottom right that this 8-cabinet array is providing high SPL and very consistent sound level and frequency response at all 5 locations from front to back along this listening plane. Note that the calculator shows you the continuous average pink noise SPL that the array can sustain continuously for 2 hours, and that's what it says right above the chart there. It's not based on peak SPL that some other companies' calculators might show. The peak capability of the system is higher than what's shown here, quite a bit higher, and the short-term average SPL would also be higher than what's being shown. So when you first start a design, I find the Get Me Started button to be very useful. It computes the program's recommended splay angles for optimally covering a seating area. You can use its suggestions, or you can use it as a starting point for then making your own adjustments. So this is the second tab in the calculator. The Array Configuration tab lets you model the physical characteristics of the array. It takes the same array that you designed in the Acoustic Mapping tab, and it tells you about it physically. You can select the safety factors you need to apply, 5-to-1, 7-to-1, or 10-to-1. It computes the total weight of the array, shows you the center of gravity point, tells you how much the weight is on the top and bottom hang points. It computes the dimensions of the array, as well as the span between the hang points. And very importantly, the calculator calls out when a limit has been exceeded, and if so, which limit it is that exceeds the safety factor that you selected. We recently posted the instruction sheet with instructions for using the calculator so that it's not hidden. It was hidden in the help section of the calculator, but it's not hidden there. Now you can just call it up and read through it. You can download the instructions from any of the VLA C model pages. Also, an ease GLL is available for doing additional modeling. We've updated the suspension bar kit. The original SB suspension bracket worked only for very small arrays. We're in the process of coming out with the SB2, which will work for longer arrays, and it helps facilitate a greater range of suspension angles. This SB2 kit comes with both the top pull-up bar and the bottom pull-back bar. These diagrams show how the bracket attaches to the top speaker, and that the bar can be rotated on an axial basis so that the eye bolts are always in line with the direction of pull. And various third parties provide some good rigging options depending on the application. For example, this is the Falcon system from Polar Focus, and they have ones that fit the VLA Compact speakers. Here's here's an example of a custom rigging frame. This is the one from Mercer University in Georgia in the United States again. The capacity of the stadium is a little over 10,000 seats, and the scoreboard speakers are the main speakers for this stadium. Okay, so here's another way of using the speakers. This is Tottenham Hotspur's football club in the UK. In this case, VLA Compact speakers are configured into highly distributed clusters all around the circumference of the stadium. If you remember me talking earlier about the challenges that are inherent with fully distributed designs that use a large number of small speakers, the wraparound from small speakers can defeat the time alignment and cause muddy sound. Well, this is kind of a hybrid design. It uses large clusters, but arranges them in distributed fashion. So you've got excellent pattern control, which eliminates the muddiness that plagues highly distributed systems. And because you can control the vertical coverage with the shape of the array, you can cover the top, middle, and bottom seating areas along with the playing field if desired from a manageable single and coherent compact line array. Here's a closer view of one of the clusters. The rigging in the venue is custom. In this case, they've got it configured so that they can split the array into 3 different sections, one for top seating, one for bottom seating, and one for the pitch or the playing field. Or they combine all the sections together to use it as a single array. You can also see that in the center of the clusters are 3 subwoofers. They're being used in cardioid configuration with the center subwoofer facing upwards to cancel out most of the sound that would otherwise project to the rear of the array. This prevents sound from reflecting off the canopy, which would degrade the quality of the bass there in the facility. So while the previous zoomed-in photos might have made it look like the arrays are huge, they're actually not visually obtrusive at all in the overall stadium view. So to summarize what's new about VLA Compact, In addition to advanced drivers for great sound quality, we're now providing a lot of new tools and materials to help you use these speakers. We've issued a number of updates to the VLA I calculator in the last few months. So if you have an older version, now's the time to update it. There are instructions for using the calculator, VFIR tunings, which also recently incremented to a new version, and there are instructions for installing the tunings. There's the new SB2 suspension bracket, along with the installation instructions for it. Instructions for the cardioid low-frequency kit, the user guide, and recently updated EaseGLL files. You can tell what's been updated by going to any of the VLA Compact model pages. Look for the date the item was uploaded onto the page. You'll see many that were updated recently. So moving on to other speakers. JBL makes a broad portfolio of speakers, many of which are very well suited for sports facilities. Many of you are already familiar with these other speakers, so I won't go into much detail about them other than to show some application photos. These are some CBT 1000s and 1000Es on tall poles with custom brackets as the outer to inner projecting sound system for a good-sized rodeo stadium. The AWC all-weather compact and full-size AW speakers are deployed throughout a huge number of stadiums, either as balcony fills, as it's shown here, or as the main highly distributed speaker system. Or AW and AWC speakers can be used for projecting from behind seating areas or at the edge of canopies at baseball stadiums. Of course, sports facilities come in all sizes. This is a small community baseball field that's covered by AWC speakers mounted on lighting poles. And of course, PD and AE speakers are extremely versatile and reliable speakers. They're often used as is for indoor arenas or can be ordered with either WRC or WRX weather treatment for outdoor locations. And many of our commercial speakers are highly weather resistant. Of course, WRC and WRX versions of AE and PD are common in sports facilities. Ones you might not think of, this is a picture of control contractor speakers with the rust-proof WMG WeatherMax grills. This is from the ISE show earlier this year. Water was being poured continuously over these speakers. The two newest NFL stadiums are heavily fitted with JBL speakers as well as other Harman Pro products. Rams Stadium, it uses full-size VLA series, plus a lot of additional speaker categories for reinforcement in the shaded areas, as well as in concourses and in back of house. And Raiders Stadium is also using VLA series in conjunction with AE series, CBT, control contractor, and PD speakers. While I've been showing a lot of US and UK facilities, there are many great sports facilities outside those areas. Here at Incheon SK Happy Dream Stadium in South Korea, I've circled every other speaker. This is primarily a baseball stadium. I might mispronounce this one, but this is a 10,000-seat stadium for the Ratchaburi Midder Pole Football Club in Thailand. Rajamangala National Stadium, also in Thailand, where they use PD series speakers. There are many different kinds of sports facilities. They come in all sizes and shapes, and each tends to have its own set of requirements. No single loudspeaker model fits them all, and no single design style is right for all of them. We've got an overview of many of these designs that I talked about on the Harman Pro case study pages. So you can check them out there. If you've got such a project, I wanted to make sure to mention that we've got application experts who can help our dealers and system designers with these kinds of projects. This was a quick overview of speakers for sports facilities with an emphasis on updated VLA I and the new VLA Compact speakers. So we're ready for questions that you might have. Laura, were any questions submitted on the chat board?
It looks like we have one in the Q&A. The question is asking, what sound adjustments are made for an empty stadium versus a full stadium?
Ooh, Brad or Jim, would either of you like to tackle that?
Yeah, I'll give it a try. I'm assuming they're talking about EQ at this point. It's, you know, an empty stadium can be, you know, I guess the point being is the empty stadium's quite a bit more reverberant. And is there something you can do to sort of help it out, because you're not getting the absorption, especially mid-band, that you might expect. So, you know, I think since the intelligibility is probably going to go down, there's some opportunity to maybe use some high-pass filtering to try to get the intelligibility back up. The reality is we don't see a lot of EQ on the run on an empty stadium. Obviously, the levels go down because you don't have the din of the crowd to sort of go over. But, you know, I think that's a lot of it. There's some other processing items that are sometimes used on a ref mic that might help that out. But you know, I think if it was me and I was looking to try to make an adjustment on an empty stadium, I'd mostly be concerned about possibly high passing the system a little bit, because that sort of you know, low frequency reverberation has a tendency to start kind of masking the mid-band intelligibility bands.
Okay, it looks like that's all that's been submitted so far. We can just hold on for a second if that's okay and see if anybody else has a question. If you do, you can enter it in the Q&A function or else in the chat box, and we'll read that off. Otherwise, Rick, are you open to receiving questions via email?
Absolutely. In fact, let me go to the next slide, and it's got my email address on it.
Okay, perfect.
So, yeah, if you have any questions, feel free to email me if it's in my area of expertise, or contact one of our, you know, regional application experts. While we're waiting for, you know, if anyone does have questions, I'll mention that, you know, sports facilities would also include, you know, places like various racetracks, both motor speedways and, you know, horse race tracks and so on. And, you know, those bring up their own, you know, design challenges. Motor Speedway, we've got a lot of speakers at Daytona Speedway, and you know, they have to go on poles. They're typically in front of the listeners. They have to be visually small enough so that people can see the action that's happening, you know, on the other side, and so on.
All right, we have a couple more questions that have come in. So the first one is asking, which best STI achieves for arenas or stadiums using those speakers?
Well, STI, as you know, most of you know, is a measure of speech intelligibility. Typically 0.5, I mean, 1.0 is perfect, you know, is the highest you can get. 0.5 is considered a threshold for a lot of specifications. And so certainly, you know, I would think, I mean, virtually every facility that gets designed in by a consultant and has an STI requirement and so on ends up meeting or exceeding 0.5. Brad or Jim, do you?
Yeah, I think, you know, for STI, all things being equal, I mean, the STI, the loudspeaker is just part of that equation, of course. The room is a factor, the noise floor is a factor, the way the system is designed is a factor. So a lot of things go into the mix of the result, you know, to get to the ultimate STI number. All things being equal, more directivity provides better directivity, provided you have everything is covered. So like we've seen a lot of distributed systems that Rick presented. We've seen some end zone systems that Rick has presented. So the idea is to try to put sound in a specific place and not overlap to adjacent areas. So this is exactly, Rick, that's a perfect slide to put up, because what we want to have happen is to improve the STI in a situation like this. We want to have each one of these arrays put a piece of sound down onto the seating, and just the seating and nowhere else. That's what we'd like to do. And we don't want it to go into adjacent coverage areas for the next array. We don't want it bouncing off any walls or roof structures. We don't want energy going behind it. So the idea is to get as, you know, the most directive, most efficiently directive sound you can get out of an array. Now, obviously, you're constrained by cost and weight and size, but that is exactly why the VLA has
and sight line and angles.
Sightline, that's right. So that's why we developed the VLA line, both sizes, is to provide the advantages of a line array, but yet still have that horizontal pattern control to help reduce this the overlap between speakers. And you know, there's a lot of other, of course, manufacturers, and you can use just regular tour sound product here, but the VLA is unique because it has the large waveguides that so that we don't have a lot of overlap of sound. They're also on the larger VLA, they're just big speakers, so you get you have pattern control down to a lower frequency in the horizontal because they're a pretty wide speaker, and you know, the pattern control is a function of how the size of it is too. And a longer array has more pattern control than horizontally. So like on some of those big collegiate stadiums we saw, we keep the pattern control better down to a lower frequency. And as when we're able to do that, you sort of start reducing we talked about this before, the masking effect of these low frequencies into that can contaminate the midband for speech intelligibility. So really these stadiums come down to speech intelligibility. That's what makes them successful or not ultimately. Of course, we want them musical, but on a football stadium, the ref mic has to work. That's, you know, that's ultimately the success of a system is how well people can understand spoken word. So larger speakers, better pattern control, careful design so you don't have a lot of overlap, and of course, if you're you know, working on the design of the system, then you know, there's a lot of acoustical parameters that you have to work with too. But as far as what is the best, you know, the best is the biggest speaker that you can get in there, really, because size and directivity makes a difference. So that's why we have different sizes of VLA, and that's why we have different sizes of PD boxes and AW boxes as well.
Well explained. Jim, did you have anything to add to that?
I was just going to say, yeah, good stuff, Brad. And I think to answer his question, yeah, in large venues, kind of like we're seeing here with the Tottenham, you know, you're doing good to get into that 0.5 range. Obviously, as the overall size of the venue gets smaller, if you have less reflective surfaces, then that number tends to go up. But generally, in these very large venues, we're doing good to get into the 0.5 range.
All right, we have a few more questions. In a situation of RT60 of 4 seconds, what's the better option, type of transducer or an acoustic planning at first?
Well, I'm definitely going to throw that one to you guys.
I'll jump in here again, Rick. I mean, we've kind of explained that, I think, by now already. I mean, you know, some of these questions probably came in at about the same time, but pretty much the same explanation. I mean, as the reverb time goes up, all things being equal, you have to have, you know, more, you know, a better acoustical a better directivity to combat that, you might say. You have to be more careful about putting sound only where the audience is and not anywhere else to try to reduce the excitation of the sound field. But at some point, you know, there is a limit. I mean, you can have a perfect loudspeaker and just cover only the seating areas, and you're going to run into a limit of just how clear or intelligible the system is without acoustical treatment. At some point, you have to treat it. But that's, you know, that's where the, you know, as a manufacturer, we can, you know, we just do the speaker part. The rest of it is the magic of the acoustical consultants.
Okay, the next question is asking, any plan to update the CVT calculator to allow for the CVT 1000E to be placed above the CVT 1000?
Oh, that's interesting. I will look into it. I believe that you can add an additional CVT 1000 and just place it there on your own, but it's very possible that when you call up the combination of CVT 1000 and 1000E, it does place it normally below it. You know, that's the location where the fronts and the backs, you know, line up, and you don't need an offset bracket to get, you know, align the fronts of the loudspeakers. But you can run it that way, and it you know, works perfectly fine.
Okay, next question, does the calculator factor in cable weight for rigging?
The VLA Compact calculator, I'm not 100% sure, but I don't believe so. That would be something I would have to look into.
Rick, we do have it in there.
Oh, it does.
We do. There is a spinner wheel for cable weight.
Oh, okay, okay. Yeah, but it won't calculate it from the cable itself. You just enter that.
No, you put in, you know, multiples of 25 pounds, which are admittedly pretty big chunks of weight. But yeah, that's, I think, a holdover from them.
Okay, thanks, Brad, for correcting me on that. Any more questions, Laura?
It looks like that was the last one. So as Rick mentioned, if you want to reach out to him directly via his email, he provided that contact information. And if you have any interest in attending our future learning sessions, we have added about 25 new sessions to our calendar. You can find that out on pro.harman.com. So thank you for attending. And Rick, thank you so much for the presentation. We really appreciated it.
Thank you, everyone.
Okay.